Yeah, now getting connected. Sorry for late. That I tried a lot and then I got the connection now. Okay, good afternoon, everybody. Am I audible now? Am I audible? Please reply. Hello. Am I audible? How come I should get know that whether I am audible or not? Oh, thank you. Same, I tried since long time. I was not getting reply, so I understood that there is a network issue. Okay. Now we are going to study about the air pollution control. Okay. So how to control the air pollution, that we will see. Okay. Now, air pollution control, we have studied about the impacts. What are the sources of air pollutants? What are the impacts of air pollutant? And now we are going to study about the control of air pollution. Okay, control of air pollution. Basically, I would like to inform you that air pollution control must be happen at the source, because it is quite difficult to control once it is emitted into the atmosphere. Okay, I will clarify my sentence once again. Imagine that the air pollutant is emitting into the atmosphere, in the open atmosphere, a single pollutant you can, and now you have to search that pollutant, or there is no such a technology to bring the emitted air pollutant back to the earth surface or back to that specific spot, is it? So it is quite difficult to control them once it is emitted into the atmosphere. So that's why we need to control the air pollutants at the source itself. If the source is the point source, it is easy to control them. If it is not the point source, then we need to apply some another technologies. Okay, so that we are going to study now as a control of industrial air pollution or the control of air pollution. Natural cleansing process is possible and control approaches. That two ways we can go for. Natural cleansing processes, in that first one is the dispersion. In the last lecture, I explained the role of stack or the role of chimney of that particular industry is to increase the dispersion of air pollutant into the nearby area. Instead of getting the this particular area, instead of getting the specific spot as a polluted one or affected one, you can make possible to disperse the air pollutants in a different direction for a certain distance from this source. Okay, then it will be possible to that process is known as the dispersion process. Okay, so this is the first way to go for the control of air pollution. That we cannot say this is a control of air pollution, we can say it is a major we can say one of the remedy for the to avoid the ill effects of the air pollutant. Then you can use, here I have written something else, but you can use some equipments like the gravity settling chamber, bag filter, electrostatic precipitator, then some scrubbers at the source, you can use it. Okay, then such flocculation, absorption, adsorption, rain out will work as a natural cleansing process. Dispersion is also one of the natural cleansing process. Naturally, it will help us to disperse or remove or drop down towards the bottom the air pollutants. Then what are the control approaches? Okay, there are two basic control approaches. First one is the dilution and another one is the control at the source, as I just now spoke. Dilution You can increase the tall stack or optimum tall height you can maintain, optimum pressure you can maintain in a particular industry to make them to possible to disperse your concentration of air pollutant into the long distance. That way it will go for dilution. It will not affect directly for that specific area. Then the control at sources, alternate fuel. Then if in a there is a vehicle, or if there is a some industry, and then they're using some fuel as a source for the conversion of energy or for generation of energy, in that case we should focus upon the towards the quality of fuel. If the fuel is a contaminated one, or maximum amount of impurities are available into the fuel, in that case you need to change the fuel. Otherwise, or we should focus towards the less contaminated or pure type of fuel instead of impure fuel. Number of impurity present, amount of impurity is directly proportional to the amount of pollutions emitting after the burning of that particular fuel. That fundamental law you should remember. Is it? Then proper use of existing equipments, operation and maintenance you should go for concentration. Then changing process, install control equipments for the particulate matter as well as for the gaseous pollutants. These kinds of remedies you can use for the control of air pollution at the source. Okay, so we are going to study one by one what type of different equipments you can use for the control of air pollution at the source. And the first equipment is the gravitational settling chamber. Okay, I will explain this, but before that, I would like to request you to go for the to draw the figure. Okay, just see this figure. I will give you an option whether you want to draw this or you want to draw this one, which I have drawn. Just give me a signal, then accordingly I will give you a display. Which one you would like to? This one or earlier one? Someone can speak fast. This one or earlier one? Which one would you like to draw? Will you continue to draw this? No one is replying. What I should imagine. Earlier one. Okay, good. Thank you, Priyanka. I will give you another option. Yeah, draw this one. I will give you 5 minutes to draw this, and then I will explain this function and working of this gravity settling chamber. Please draw it. Have you done, guys? Shall we move? Explain. I hope you have finished. Have you done? Okay. I told you that emission of air pollutant, once done, it is quite difficult to control them from the atmosphere. It has to be controlled at the source. And source in the sense, especially if industry is producing a huge amount of pollutants. In that case, we can control. It is a point source. We can control at the source. Before, now, these are the different equipments we are going to study which can be applied for the control of industrial air pollutants. For the control of industrial air pollutants. And in that, the first one is the gravity settling chamber. Okay. In that, first one is the gravity settling chamber. And the next one is the bag filter, cyclone separator, scrubber, electrostatic precipitator that we are going to study. So the first of all, we will discuss about the gravity settling chamber. Is a controlled equipment. It is a stable, or we can say it is a stationary type of equipment. There are no movements are being observed, or the mechanical movements are not available in the gravity settling type of chamber. So the gravity settling chamber is it is a simple equipment, and it can be used for the collection of solid particles. Okay, I think you understood there are two types of air pollutant. One is the solid particulate matter. We can say it is a dust particles, or we can say it is a particulate matter. I told you PM10, PM 2.5, PM50. So that is the size that indicates the size of particulate matter. Okay, it is simply, you can say it is the dust particles, which we can control with the help of this equipment. Okay, and another air pollutant are in the gaseous form, which are difficult. It is quite difficult to control them once it is emitting into the atmosphere. Okay, so how to control? By using particulate matter, sorry, by using gravity settling chamber. Gravity settling chamber is made for the collection or the removal of particulate matter, means dry particles, we can say. It consists a chamber. You can see this is a chamber. Okay, it consists a chamber, and in this chamber, a carrier gas in the sense which we want to treat. Carrier gas second. This is a chamber. Through this, you can see. Let me take the pencil. Through this inlet, the carrier gas will be allowed to enter. And here, the arrangement or the design of this gravity settling chamber is made in such a way that it will reduce the velocity of inlet flow. It will reduce the velocity of inlet flow. Once the velocity of inlet flow is getting reduced, the velocity of particle will also get reduced. And hence, instead of particles flowing in a forward direction, it will start falling down here. And it will fall down as per its size. Where it is going to be fall down, it will depends upon the size and shape of that individual particulate matter. Are you getting? So this is a simple horizontal container inlet outlet arrangement. This you can say height of the chamber or diameter of the chamber. And this will be the length of the gravity settling chamber. And these two are the hopper bottoms for the collection of dropped particles has been created over here. And the inlet velocity, whatever the inlet velocity is given here, it will be reduced when it is coming into this area, because the area has been increased. So simply by this simple law, it will increase the velocity of inlet flow. Due to that, particle velocity will slow down and it will start falling down into the hopper bottom. Is it? So this equipment is applicable for the particulate matters whose size is greater than or equal to 50 micron, not less than that. Means it is a very primary type of equipment which you can use for the control of particulate matter as an air pollutant from the industry. Are you getting? Remember that factor, greater than or equal to 50 micron. Velocity, you should maintain the velocity in the range of 0.5 to 2.5 meter per second. If it is less than 0.5, it will not work effectively. If it is greater than 2.5 meter per second, there will be a possibility of re-entrainment. What is meant by re-entrainment? I will erase whatever I have drawn, then I will explain re-entrainment. So what purpose we are going to, we have constructed, we have made this arrangement. We have made arrangement to make the particles to fall down and settle at the bottom. But if the inlet velocity is greater than 2.5 micron, at that time, it will not allow to fall down the particulates, but also if the particulates are settled down, that also it will being re-entrained along with the velocity and it will flow along with the gas outlet. Okay. So that's why you need to take care of the velocity in the chamber. Okay. So the laden gas is coming in through this way. Particles are falling down and the clean gas is going out through the another end of through the outlet, which is arranged at the another end. Okay. Now, advantages. What are the advantages? Low initial cost, a simple construction, no maintenance is there, a low pressure drop, dry and continuous disposal is possible. Disadvantage, it requires a large space for the large particles. Its efficiency is specifically for the greater than or equal to 50 micron, not for the smaller than this. Means you can use this equipment as a primary equipment for the control of air pollutants into the from the industrial air, industrial outlet. Okay. So one more equation I will explain with the help of another file. So I will stop sharing of this and I will share another that PDF which I have shared earlier. Okay, you can see here. Gas inlet, length, this is height. So velocity which is applied for the gas will be V, or the particle velocity Vs can be towards the bottom side. This is a hopper bottom. This is a clean gas. So from that we can mention the equation. You can see a simplified analysis of the gravity settling chamber assumes that the solids move along the chamber with the velocity of gas and also settles with Stokes velocity. The particle entering the chamber at the top will be collected by the chamber if its settling time is same or less than the time the gas takes to pass through the chamber. If the settling time is equal to the time or less than the time required to pass the gas towards the outlet, is it? So in that case, the particles will settle down, or we can mention that equation mathematically in this form: H upon Vs. H is the height, Vs is the settling velocity of particle. H upon Vs is equal to L. L is the length of this chamber and V is the horizontal velocity of the gas. It is a horizontal velocity of gas, L upon V. Then in same equation, we can convert in the form that Vs is equal to H into V upon L. This is the equation number 1. Okay. Then by Stokes law, Vs is equal to, you know the equation for by Stokes law. What is the equation for settling velocity? That is what mentioned over here. That is Vs is equal to G into rho p minus rho into d square upon 18 into mu. Rho p is the density of particle. Rho is the density of fluid. Here density of fluid is the gas. D is the diameter of the particle. Is it? Diameter of the particle. G is acceleration due to gravity, and mu is the viscosity of the gas. Okay, so this is the Stokes law equation. Then if we can compare these two equations, that equation number 1, Vs is equal to H into V upon L, and Vs is equal to G into rho p minus rho into d square upon 18 mu. When we compare these two equations, we will get the equation as in the form of D, diameter. That is, D is equal to 18V into H into mu upon L into G into rho p minus rho raised to 1/2 in the, that is what? Under root. Okay, so you can, if you will solve these two, compare these two equations, it is not possible to me to solve this equation on this laptop. That's why I am explaining with the help of earlier notes, by taking the support of earlier notes. Okay, so please cooperate and understand. If I'm in I would have been in college, I would have explained on the board the way I have explained the earlier chapters. Okay, so if you wish, you can write down, or I will share this file with you. Let me know what do you want. So from this equation D, from this equation, we can calculate the minimum size of particle which can be removed with the help of this equipment. Minimum size of the particle which can be removed from this equipment, existing equipment, that is settling chamber. Okay, so if you wish to write down, I will give you, I will open it for you step by step. Otherwise, I will share with you a file. Let me know your answer. We have less than 1 minute time. So anytime we make it exit, we need to get reconnect. Time being, send me your answer so I can arrange accordingly.